This is the demonstration of a simulation modeling approach for vehicle routing problem in cluster-based pharmaceutical supply chains. The developed model consists of 7 distribution centers and 19 customers located in Iran, where every DC is connected to each customer. This network design was used to distribute all the identified clusters of the pharmaceutical products in the industry. And the data sources are the CVRP library and test cases from literature. This simulation was done using the supply chain guru modeling and simulation software, where 6 main tables have to be populated. Now you can see the sites table where 26 sites are being populated. Here is the products table, and then the demand table, the sourcing policies, where every DC is connected to each customer, the transportation policies, and as the 6th table, inventory policies. Having populated all these tables, we can visually view the network design that we have done using the visual modeler. Here you can see the design that we have done. That is using the visual modeler. And next we move on to the map, where all the locations that we have cited are depicted with all the possible links, and here without the links. Having done our network, we will now simulate the network in order to make sure that the design is in place. Now the simulation has been started. The simulation has been completed, and using the summary report, we can see the network simulation output summary. Since the focus of the study is transportation optimization, we have to populate 4 more tables, and those are the shipments table, the transportation assets table, the asset availability, and the rate table. Once those tables are completed, we move on to the transportation optimization. First, we move on to the options, and we can select the duration that the shipments have to be considered. Once the options are set, we can move on to optimize the transportation problem. Here we run the transportation optimization. The transportation optimization has been successfully completed and there are 146 unrouted shipments, which could be due to resource constraints such as asset availability, business hours, or cost constraints, which has to be addressed by the organization. This is the map where we can see the route layer with all the routed shipments. And this consists of all the shipments, including the unrouted shipments as well. We have the option to show routes one at a time. The optimization gives several outputs, and here the transportation optimization summary is given where total system cost can be evaluated. Moving on to each cluster, which are the scenarios. First, time-sensitive products are considered, where minimum time is utilized in delivering the products. The scenarios are created in order to make sure that the variables utilize minimum time. This is how to create scenarios. Then we run the scenario to do transportation optimization. Here you can see the cost is reduced as well as the number of unrouted shipments are also reduced. This is the optimization summary which shows the reduction in cost. And this is the map of that particular cluster. Moving on to the hazardous pharmaceutical product cluster, individual treatment in product transportation is done. First, the baseline scenario is conducted and the optimization gives the system cost in transportation. Once the baseline scenario is run, the sites and customers are treated as individuals. Then again the transportation optimization is run. Here also the cost is reduced and the number of unrouted shipments are also reduced. This is the summary. And here is the vehicle routing path map. Here the details of the optimization are shown. And this is the route summary where the total cost, distance and the quantity is shown graphically. Moving on to the hybrid pharmaceutical product cluster, minimum time utilization in delivering the products and individual treatment in product transportation is considered. Here also the baseline model is run and the total transportation system cost is obtained. And then the model is run again with all the changed variables and features. Here also the cost as well as the unrouted shipments is reduced. Hybrid product cluster incorporates the features of time-sensitive and hazardous product cluster. This is the summary. And this shows the map of the hybrid product cluster where the vehicle routing paths are depicted. Next, the general product cluster is considered where distribution is similar to that of commercial goods, where aggregate transportation is considered. At the same time, we'll consider the condition-constrained pharmaceutical product cluster, where the arrangement of products is done in required conditioned and well-sealed containers, and here also aggregate transportation is done. Here the conditions considered could be the temperature, pressure, and other features that are required in transportation. Since both these clusters considers aggregate transportation, one model is run to simulate the features of both the clusters. To depict aggregate transportation, a baseline model is run where the system cost is obtained as before. And then the sites and the customers are considered in the function aggregate into group. Afterwards, again, the transportation optimization is run. Here also, the cost is reduced than the baseline model. This is the summary, and this shows the map. As a conclusion of the study, it can be shown in this graph where the cost is reduced when the product characteristics are inherited. This shows a comparison between the baseline model and the adapted model. Here the reduction in total transportation cost is shown as a percentage. As a conclusion, it can be stated that the overall cost is minimized when the pharmaceuticals are routed to better suit their product characteristics rather than distributing the products without considering the inherent product characteristics, which are dynamically modeled and evaluated to provide better quality products to the patients. Thank you.